Okay, we are live. Nicko, do you want to do an introduction and then we'll take it away?
Sure, I'm happy to do so. Yeah, my name is Nicko Guyer, and I'd just like to also introduce Shadman today, who is the manager of emerging technologies at CGI Federal. And Shadman and his team at CGI Federal have been using FireFly for a while and have found it has really accelerated a lot of different use cases in their business with some of their clients, and just really excited to have him here today to present, to talk to you all about the different ways that they found FireFly to be useful and to accelerate their business. So the first part of this webinar, Shadman is gonna talk and kind of describe some of those use cases. After his presentation, I'm gonna jump in and give a brief live demo of FireFly. Maybe you've seen it in action before. Hope this is probably a slightly newer demo than maybe one you've seen before. And so we're going to really focus on like the developer power of Hyperledger FireFly and how it accelerates development. And I'm going to try to tie that back to use cases that Shadman is talking about. So that's kind of the plan for this webinar. And Shadman, thank you so much for being here, and I'll turn it over to you.
Thank you for having me, Nicko. This is really exciting to just share the journey that I've had within this space. So I'll go ahead and get started. I'll be talking about driving digital transformation within government with Hyperledger FireFly. So as Nicko mentioned, I'm a manager within the emerging technology practice at CGI Federal. And the agenda today that I'll be going over is, if I could get my slides to go to the next one. Sorry, there we go. I'll just do a brief introduction of CGI Federal, and then talk about setting up the stage with Web3 and Zero Trust, why governments need Web3, and then I'll be diving into some of the use cases that we're focused on, and then how Hyperledger FireFly enables us to move at the speed of mission, and then open it up for some Q&A. So CGI Federal, CGI is actually one of the best kept secrets if you haven't heard, but CGI Federal is a subsidiary specifically focused in the US market. We're about 7,000 members within CGI Federal, and we have hundreds of clients within the federal government, from Air Force, Navy, Marines to civil. We run all the financial platforms for a lot of these agencies. So just wanted to, be cognizant of the CGI Federal footprint. We have offices all over the United States, as well as the global footprint. Now, what my team focuses on specifically is the emerging tech around Web3. Now, most of you guys on this call know Web3, so I'm not going to go deep, but just as a refresher for anybody new, Web 1 was in the early 90s, and then we went to Web 2, and now we're moving towards this decentralized version of the web. Now we're calling this Web 3. And many people just focus on just the blockchain aspect of Web 3, but the definition of Web 3 to me includes AI-driven data services, edge compute, as well as the talks of Metaverse. So Web 3 just isn't about blockchain, but this talk will be focused specifically on the blockchain aspect of Web 3.0, and that's what my team focuses on. So this is the bigger vision that we have, is how do we enable digital transformation across industries, whether that's defense, supply chains, academia, healthcare networks. Imagine a world where you can integrate these different systems across different industries without needing to trust anyone. And this idea of zero trust, that you have to verify before access. You don't trust any user. You don't trust any device. You don't trust any network without verification. And that's the bigger vision of zero trust. And I think, Web3 will play a big role in making this vision come to reality. Now, the question is, why do governments need to move from Web 2 to Web 3? As you know, Web 2, the biggest problem we see is the architecture. The main problem is the data silos prevent data sharing in real time. We have all these point-to-point connections everywhere. And that's the reason why very few companies and government agencies have been truly able to collaborate and leverage their data. Now, on the right-hand side, you see this Web3 data architecture. And this decentralized architecture is designed to break down these data silos. And you see Hyperledger FireFly is the center of it all. That's sort of connecting this whole ecosystem. And we're focused on 4 things primarily, which is trusting the untrusted. You know, how do you allow interoperability between these systems that don't inherently trust each other? How do you get auditability and traceability, right? That's the huge aspect of blockchain, the immutability aspect. How do you collaborate in real time with incentives, with aligned incentives for all the parties? And how do you do all of this at the speed of mission, right? That's what Web3 truly enables. And so this is sort of what I think the building blocks of Web3 is, specifically in government. And these are layers that, you know, I've identified, not necessarily, you know, something that you as a blockchain project need to have all the layers, but this is where you would have to start at some point. And now this could happen at the identity layer or the governance layer, but let me walk through these layers. So the identity layer, as you know, is this digital identity or decentralized identities for all humans, devices, assets, and it could eventually be AI agents as well, right? So this identity layer sort of is the first anchor point into your Web3 journey. Now this, you know, the United States, DHS and a few others are looking at implementing identities and with zero knowledge and privacy aspects. And this is something that the government is actively seeking, and we need solutions at this layer. And then from the identity layer, you move on to the access control layer. How do you put granular access controls on the identities itself? And then you move on to the immersive layer. Now, there's some people might call this the Metaverse layer, but this is now the visualizations of all the data, whether that's your identities, who's accessing what. Once you have the immersive layer built in, the next layer is the incentive layer. And this is where you leverage the idea of tokenization, certification, NFTs, sort of aligning the incentives in the ecosystem. And the last, but the most challenging layer, in my opinion, is the governance layer. Now, this is the infrastructure layer where collectively communities are deciding what to upgrade in the ecosystem. Now, you know, I include that as the last and the most challenging layer, but you know, you sort of think about this is not a linear building block. This could almost be a circular layers of building block where each is building on top of the other. So with the building blocks, now let's talk about how we're leveraging FireFly for zero trust use cases. For some of you that don't know, there's an executive order by the president on improving the nation's cybersecurity. There's a for the adoption of zero trust architecture. It's known as ZTA. So all federal government agencies are mandated to move the government systems toward a zero trust architecture. So my team is leveraging Hyperledger FireFly to implement these zero trust principles for our federal clients. Now, let's talk about one of the first use cases that we're focused on, which is in defense. How do we transform the DoD supply chain with zero trust? The problem is there's a huge lack of trust as well as audit compliance within defense and DoD supply chain. The DoD has never passed an audit ever in its history. And it's not that there isn't data, the data is there, but how do we make the data auditable, trustable? So, you know, the question we like to ask is, can we bring this trust to DoD supply chain with Web3 technologies? I believe we can. And using things like FireFly, we can establish those trusted identities, trusted assets and transactions that will improve the traceability, the visibility, and transparency into the DoD supply chain. Now, this could be a bit controversial, but I believe this will help the DoD better maintain and get transparency within their supply chain, as well as help them pass audits using a Web3 based system to keep track of the supply chain. The second use case that I'm super excited about is in space. Now, there's a lot of push towards space startups. Lots of folks are getting involved, and this is the new economy is being created. But the problem is, how do you trust what's coming from space? How do you trust space data? So one of the things we're looking at is tokenizing space data, whether that's images, assets, that's coming up from space. Tokenizing that data allows us to then trace what's really happening and trust that data. The other part of this is enabling democratization of liquidity into the space economy. So now imagine if we open up a ecosystem for the space economy that enables anybody in the world to invest in these space companies, invest in these space assets. That's where Web3 can really open up new opportunities. You get increased liquidity, accessibility, and transparency and trust. Now that there's of course challenges, how do you scale with limited computing and all that? But I believe we are at a point where we can address these challenges with these, scalability solutions such as zero knowledge. But I believe there's a big opportunity to create this space economy with Web3. So the question, and I'm super proud of this, but can we create zero trust economies in zero gravity environments? And this is to just feed your imaginations, right? What are the possibilities? And I think there's a massive opportunity at this intersection. And my team is doing some awesome things in this specific space around tokenizing space assets. The next one I'd like to talk about is the metaverse. So as you know, with AR, VR, and you might have heard of digital twins, these assets that we're creating that replicate the real world could be very, very sensitive. So how do you maintain the security and the integrity of these metaverse objects and these digital twins in the metaverse? You might have seen certain platforms that are already using blockchain-based systems as the backend for their metaverse. So we're leveraging Hyperledger FireFly as that framework for creating, securing, tracking, and managing these metaverse assets with specific access controls. Now, the benefits we get is you get enhanced digital twin security, you get that provenance, you get that interoperability and compliance. And so when it comes to building very sensitive metaverse objects, the question becomes, how do you then safeguard these sensitive metaverse assets from theft, from potential tampering, from potential unauthorized access? And so this is a big conversation because, public blockchains don't necessarily have those access controls. So if you're creating these super sensitive metaverse assets, how do you then put access controls on it so only specific individuals that have the right to see it can access it and see it, nobody else? And this is where we've done a lot of work with universities, specifically with George Mason University, to build out what we call Beacon, blockchain-enabled access control, leveraging Hyperledger FireFly to enable this capability. The next one I'd like to talk about is healthcare. Now, we know healthcare is super outdated, and it's super painful. Every time you go to a doctor's office, you sort of have to keep creating and submitting the same forms over and over again. And so, if you switch hospitals, same issue occurs. You have to sort of transfer all that data to a new provider. And you have all these data silos that cause these issues and privacy concerns in healthcare. And I believe using Hyperledger FireFly, you can create secure and compliant data sharing platforms using the zero trust principles that would give you, the patients or the physicians, power, whether that's owning the power back for the patients to give access to the data to the doctor. So imagine if you're a patient, you control your own healthcare records, and this enables this accelerated medical research. That's the other aspect of this is when the pandemic happened, COVID, how do we share data from across continents, across Europe, across the US, across Asia, collaborate to figure out what's really happening in the vaccine supply chain, in the medical research. And so Web3 could really disrupt this healthcare space by accelerating the data sharing in a zero trusted way that would also enable privacy. And of course, you want to make sure that this all follows the regulations, whether that's GDPR or PII laws. And this is where not just the transparency, but the privacy aspects and the promises of things such as zero knowledge proofs really shine. And last year, we created a digital, we call a healthcare digital wallet with University of Tennessee that created a proof of concept to enable a digital wallet where you can store all your healthcare records, whether that's X-rays, your own yearly checkups. Imagine giving access to the doctors or the hospitals or somebody that needs to see that data for medical research. Imagine you being in control, right? That's the vision that Web3 would allow, specifically in healthcare. And I know that healthcare industry is one of the toughest industries to disrupt, but I think this is where all the citizens of the world can benefit, and also scientific progress can happen at an accelerated rate. Now, I saved the best for last. And this is around the topic of AI. As you know, AI is the biggest hype and the biggest buzzword right now. And everybody's talking about AI, but nobody is necessarily focused on responsible AI. And the biggest problem that I see right now is the lack of transparency within the AI systems, whether that's OpenAI, whether that's Google, whether that's Anthropic. All their AI development right now is in a black box. And we're sort of trusting their processes. And they're claiming that they've gone through audits, they're compliant, but how do we know that's true? Can we actually verify and validate that they do not have biases, right? And so this is one of the biggest problems that I see that Web3 can actually fix. And I see this as one of the biggest use cases for blockchain systems, specifically public blockchains, but of course, with privacy functionality. And I think Hyperledger FireFly and just Web3 in general can enable this transparency and accountability in AI. We can use not just for transparency, but other benefits such as protecting against bias. Is it being done ethically? We can potentially even rewind an AI's decision using that audit trail. The benefit is truly to create a sustainable ethical AI. And I think that's a win for humanity. And so the question now becomes, how do we create these transparent, accountable, ethical AI systems for government use cases without necessarily, without stifling that innovation? And you might know, the CEOs of these large companies are meeting with Congress and having these discussions, but most of these discussions are also happening behind, closed doors. And so that's one of the problems is we need to get transparency into the development of these systems, because if you watch the movie Terminator, Skynet, that's where we might be headed. And a lot of folks such as Elon share that sentiment, that if we do not put guardrails around AI development, we are going to go down a dark path. But the beauty is we have the technology, we have Web3 as even a concept that can solve these issues. Now, we as citizens of the world need to come together and demand that transparency, demand that accountability within the development of these AI systems, because this is going to affect all of us. So with that, I would like to just summarize how Hyperledger FireFly has just enabled my team to focus truly on the business use cases. As you saw, all the business use cases that I've talked about would have taken years to just build one of those. But with something like FireFly and the power of open source, it's truly enabled us to just focus on the use case and focus on the mission. instead of, focusing on building all the off-chain plumbing, spending 2 years building all of these things from scratch, our team within a week has been able to create new use cases as we talk about, identifying problems with our clients. We can create POCs and show that ROI within weeks. And so that's, technology is accelerated the adoption of everything. And now having something like FireFly will save, any team, but specifically our team, it has saved, I would say, thousands of development hours as well as resources, and has accelerated our clients' return on their investments. And so with that, I will, invite everybody to join us in transforming the government's, using progressive decentralization and Web3 technologies. And I'll yield back to Nicko.
Awesome. Thank you so much, Shadman. Do you want to pause for Q&A on the slides now, or do you want to jump over to the demo now and then do Q&A for everything at the end?
We can pause and go into some Q&A. I think we have folks from all around the world, so let's see.
Yeah.
Let's see what we got.
And maybe we'll cap it at the bottom of the hour, so that gives us roughly 10 minutes of Q&A, and then we'll switch to the demo. Does that sound good?
Sure.
Okay. Awesome. If folks have questions, you're welcome to drop them in the chat, or you should have the ability to unmute and ask your question. If you just want to raise your hand, I'll try to call on you here as well. Shadman, how do you manage the user in Zero Trust? The question in the chat.
Well, that's a great question. So there's a concept of admins, right? There's administrators everywhere that would, in the Web2 world, sort of play that role as management of users and access control. And there's this notion of multi-signatures within, the Web3 space. And so one of the from our research with George Mason University, when we created that beacon module, there was several approaches we took. One of the approaches was a multi-signature, almost a DAO-based administrating that would enable the users to be managed under that zero trust principle. Because at the end of the day, you don't want a single admin to have super user rights, right? So that's sort of a root problem where you can do insider threat, insider attacks. You can pay a systems administrator to maybe delete a record or add a record. So having multiple checks, having multiple approvals, and not necessarily having a sort of root super user would be the way you manage that the users in zero trust manner. I hope that answers the question.
Awesome, thanks. Next, we got, what VC types do you create for trust verification in zero trust use cases?
Well, that's a great question. So VC types, they're talking about verifiable credentials, I believe, not venture capitalists, right?
I think so, yeah.
Yeah, so when it comes to verifiable credentials, as you know, there's this verifiable credential data model that's out there. And there are different implementations of this. And so when you read and look at the verifiable credential data model with the verifier, the holder, and then the issuer, you have different ways you can implement it. And so that truly depends on the use case. And there's actually been a program from CBP, Customs and Border Protection within DHS, to create a privacy preserving digital wallet that would enable the United States, anybody coming in and out of the country, to sort of validate and verify your identity. And so this problem has not actually been figured out yet, but I believe things like zero knowledge would be critical in that verifiable credential architecture, where you can hide the key details around your birth date, where you're coming from, but be able to mathematically prove that you are saying that the true information. So I think there's still a lot of R&D that needs to happen within the verifiable credential ecosystem, specifically at the verifier layer. So if you're a verifier, how do you verify that the holder actually has that correct asset? So, I don't have a clear answer, to be honest, but there is, R&D specifically at that intersection of verifiable credentials and zero trust, and how to do it in a privacy preserving way. So if you're focusing on that problem, I think that is a great problem to focus on.
Awesome, thanks. Just a couple other questions here. Is the idea to use an ecosystem or open platform in both sides? How can blockchain, oops, sorry, the chat's moving. How with blockchain can developers build on this? I'll actually take a quick stab at answering this question, and then happy to let you add any detail to it. But the idea with FireFly is it's both. It can be both. You can have, and it allows you to build applications and networks that span both private, what we call multi-party networks that maybe have very sensitive data in them, and you want to run at high transaction throughput, high speed, zero gas cost within a private chain. But you may also need to, at the same time, connect to a public chain to provide that transparency or that trust to the rest of the world. And FireFly allows you to connect to both types of networks at the same time. And so we've seen some really interesting flows where you can be performing your business transactions within a private chain at high speed and high throughput with zero fees, so that you can control costs, and then pin data that's happening on that private chain to the public chain, or rolling up data. And there's lots of different strategies there about how do I push data in a way that still preserves the privacy of the original data in my private network, but puts proof of something that happened in that network on a public chain that anyone could verify. And so FireFly can enable these types of use cases really well. Shadman, I don't know if you have anything that you wanted to add to that.
The only thing I wanted to add there, I mean, you hit it on the nail. The only thing I wanted to add there was the fact that I see, this whole space as a spectrum. When we say decentralization with public and private, right? The goal is you can start off private and enable, work with customers that aren't comfortable with putting all their data on the public chain. But the goal is to progressively decentralize and have that ecosystem where private, permissioned, public can all sort of work together in one ecosystem. And FireFly is a great connector for that.
Awesome. We've got a few more questions here in the chat. Just want to be cognizant of time, and we'll probably take one more question. Shadman, I don't know if you want to, if you're keeping an eye on the chat here, if there's one of these that you want to take before we switch over to the demo.
Well, somebody's asking, I see, about the healthcare wallet. It's still in the testing phase. So it's not out for release to be used by patient, but also, healthcare is one of the slowest changing industries. So that's going to be an uphill battle. I don't think it will be ready anytime soon. Let's see. In terms of viewing the data, how is it ZK based? Yes, that the healthcare aspect, I think zero knowledge is going to play a big role, and not just ZK. I think other privacy preserving mechanisms, you might have heard of homomorphic encryption, potentially things like trusted execution environments. So I think it's not just zero knowledge, but it's going to be a combination of these privacy preserving techniques that they're out there that will address that issue around recovery, compromised keys. I think that specific aspect, if you look at MPC and multi-party computation, I think Nicko, feel free to add in here, but FireFly is a great multi-party computation platform that would also enable you to address those concerns.
Yeah, absolutely. Just one other quick question here. Somebody asked, how can we collaborate? I'll just drop a quick link here to the Hyperledger Discord server, and you can find the FireFly community. There's a FireFly channel there. I'm in there every day, and as well as the other FireFly maintainers. If there's something here that you're like, hey, that sounds really exciting, and I want to have a conversation after this with someone to continue the conversation, that's a great place to get plugged in to chat with us in real time, ask questions. If you see the demo today here that I'm about to do and you want to go try it out and you need help walking through it, feel free to find me there. But that's a great place to get plugged in with the broader FireFly community. All right, with that, just due to time, I'm going to switch over and we're going to do some hands-on demo now. And I just loved all the different use cases that Shadman walked through and some of the really exciting things that can be done with Web3 and how FireFly is enabling those use cases for his team at CGI Federal. And so what I'd love to do is just walk through now how easy it is to get started with FireFly. And I'm not going to build out an entire use case that Shadman has described, but hopefully just give you the taste for like, this is how easy it is to track something in FireFly, to tokenize an asset and to track that through the system, and to exchange data, and sort of give you a feel for like, this is how the building blocks of the system work. And then hopefully from there, your creativity can take over and you can imagine how to build the rest of your use case using FireFly. So I'm going to go ahead and share my screen. And what I have done in the background is I've just gone through the getting started guide of FireFly. So I've gone through getting started and I've set up the FireFly CLI on my machine. And I've started up an environment, and so I have 2 FireFly nodes running on my machine. And I just did that ahead of time to save some time. So if we go look over here at, I take that back. I actually haven't started it. So I'll start that up while I talk here. So that's going to start. And while that's starting up, I'm going to briefly talk about the demo that we're going to walk through. So I have open in VS Code, and if you're not a coder, that's okay. Bear with me. My goal is to show very little code. And the point of this demo is to show how much you can do with FireFly with very little code. This is one of the things that Shadman was talking about how many thousands of hours of development time that FireFly has saved his team. So today I want to show you one of the samples from the FireFly samples repo. And if we go into this directory here, fungible to non-fungible, we just have a little demo. It's a very simple TypeScript app. It was originally demoed with a Polygon testnet on a public network. Today I'm just going to be running everything locally though, because that's a little bit more streamlined. But the gist of it is the same. So you can ignore the fact that this is Polygon. But essentially what we're going to do is we're going to deploy 2 separate token contracts to the chain. We're going to have FireFly running here, and then we're going to have our sample app running over here. This is the sample TypeScript code that I'm about to show. And what's going to happen is we're going to subscribe to events from both of these contracts. And when someone transfers our some ERC20 tokens, this is a fungible token. So you can think of this as like coins or maybe credits within this network that we're building. We're going to mint an NFT and send that back to whoever sent us the ERC20 tokens. So you can imagine this use case is like, maybe this is a data marketplace, and you have an ERC20 contract that tracks maybe your credits that you have earned in the marketplace or in this ecosystem of organizations that are working together. And the ERC 721, the NFT, represents your ownership of some sort of asset or something that you have earned. Maybe it's a badge, maybe it's the rights to a certain data set within the network. The token can represent whatever you need it to in your particular use case, and it can point to whatever off-chain data you need it to point to. So the goal here is to demonstrate the mechanics of like, this is how we can swap from a fungible token to a non-fungible token and perform that exchange. So the app is going to be listening to events emitted from FireFly. And then when certain conditions are met, it will tell FireFly, okay, great, go mint this token, send it back to them. I'm going to demonstrate this with both sending and receiving the tokens from FireFly. And I'm not going to use a mobile app, but I will use a separate wallet app as well. And we'll come back to this picture in just a little bit as we go along to help people track where we're at. Okay, so in the background, while I've been talking, our FireFly nodes have started up here, and I can open up the Explorer here for this FireFly node. So I've gone ahead and just for clarity, I have. Sorry, I'm going to try to move this little Zoom window out of my way here so I can click on things. I've named my organizations in the network. I've named them Alpha and Bravo. So this is the Alpha node. And if I go over here, this is the Bravo node. And each one belongs to a different organization. We have Alpha Corp and Bravo Inc. are the two organizations in our network here. So we can see those in the network map here, just to be able to see on the dashboard which FireFly organization we're looking at. Okay, so we've got that running. That's great. I'm going to go hop over to the project source code now and just kind of walk you through. Here's what's going to happen. So like I said, my goal is to show very little code. So this is just one file. This is TypeScript, and we're just going to be using the FireFly SDK here. When our app starts up, it's going to create a subscription, and we're going to filter on token transfer confirmed events. In FireFly, there's lots of different types of events that you can subscribe to depending on what your application needs. And you can get pretty granular with filtering those down to just the very specific things you need and to optimize your app. But right now, we're just going to be looking at token transfer confirms. And then we're going to tell FireFly to start listening, the FireFly SDK to start listening for events. And we just have a really simple event handler function here. So basically, we're looking for, is this a transfer to our fungible pool? And if it is, then was the amount sent? Basically, we defined over here in our constants that an NFT costs 10 tokens. So if you send 10 ERC20 tokens, we're going to mint you an NFT. Okay, so that's what that math is doing here. We're going to log that we received however many tokens were received from the address that sent it. And then if the amount is greater than or equal to the cost, then we'll tell FireFly mint a token, and we'll mint one in the non-fungible pool, and we'll send it to the purchaser. And then we'll log that we minted it. And then the app will just close when we hit Control C. That's all this code does. So that's it. That's the whole app. So this is how to bridge ERC20 to ERC721 in 65 lines of code. Obviously, for a production use case, there's a lot more things that you would want to check, and a lot more that you would want to put in to make it robust. But like, this is the kernel of the functionality here, and this is what I wanted to show today. Okay, so to set this up, we just need to grab a few of these environment variables here. So what I'm going to do is I'm going to go back to when I ran everything. It also gave me this URL to the FireFly Sandbox. FireFly Sandbox, if you haven't seen it before, is a great little tool to kind of try out FireFly rather than making HTTP requests manually with something like Postman or something like that. You can actually try various FireFly functions right here in the web UI in the sandbox. So I'm going to actually create my two contracts here. I'm going to create we'll call this one credits. And we'll just make the symbol cred, and I'm going to hit run. And this is actually going to deploy an ERC20 using a factory contract that was set up automatically by the FireFly CLI. And then I'm going to create one called assets. And this is going to be a non-fungible token here. Okay, great. So those are both created. I just need to grab the token pool IDs for these so I can look in this thing right here. And then if I go back and read the README for this code that I'm running, it will tell us that we need to set some environment variables. So I'm just going to set those real quick. Set our fungible pool ID. And I'm going to do this in my VS Code window here. I'm going to go through this quick. this is being recorded, so if you want to go back and try this yourself later, you'll have the recording to reference. But sorry, sandbox. Here we go. Okay, so this is our fungible pool ID. Put that in my environment variables here, and then we're going to export the non-fungible pool ID and set this one to this one right here. Okay, and the last thing we need to do is tell the sample app what our FireFly address is, what the wallet is that it's using. There's a couple ways you can get that. You can look in the FireFly Explorer. You can go down to Network Organizations, and you can see, so we're looking at, this is the Bravo org here. Let's look at the Alpha org, because that's the one that we just deployed the contracts with. So we're going to do that one. So if we look in Network Organizations, Alpha Corp is, here's the Ethereum address under the verifiers here that Alpha Corp will use when it signs transactions. So we're going to tell, there's one more environment variable that we need to export. That is FireFly address. And that just tells our sample app what address it should be looking for transfers to. Okay. So that should be it. If you just cloned this, you'll also need to run npm install. I've already done that, so I should be able to run npm start now. And this will start up. Okay, it's running. It says FireFly WebSocket connected. And so the app is just listening now. Okay, that's great. So now what we need to do is we're going to go mint some tokens. We're going to give Bravo Inc. a set of credits within our network, and then Bravo Inc. will be able to exchange some of those credits for an NFT. Okay, so to do that, I'm going to show you a slightly different interface now. So instead of going to /UI, I go to /API. I can see the Swagger API for, this is for my, so this is, I'm using FireFly, the FireFly Alpha node here, the Alpha Corp organization. And I'm going to scroll down to the tokens endpoints, and I'm going to do a token mint. And so I'm going to mint some tokens directly to Bravo and give them some credits. So I'm going to set the amount here to, I'm going to give them 100. This particular contract has 18 decimal places. So, okay, 18 zeros after that. If you're familiar with how Ethereum works, you'll know why I did that. There's no floating point math in Ethereum is the short version of that. Okay, I'm going to take a couple of these extra, with some of these fields we don't need, they're optional, so I'm just going to take those out. And for if this were a non-fungible, we would add the token index and URI, but it's not, so we don't need that. Okay, so here we need to tell it what token pool we need to mint these in, and this is going to be in our fungible pool for ERC20. I'm going to copy this ID here. And then we have to tell it who we're sending this to. And so for that, I'm going to go get the, oops. I'm going to go back and look at my organizations. And grab Bravo's Ethereum address. So we didn't copy that earlier. Okay, and I'll put that in the to field. Okay, so we're going to mint. This is 100 followed by 18 zeros in the ERC20 pool, and we're sending it to Bravo. We're going to run this. Okay, it was accepted. It's a token transfer. And let's go check our FireFly Explorer now, see if we can see that in there. Indeed, we see a token transfer that was confirmed. And if we go look at our tokens tab, I didn't show you this earlier, but we've got our two token pools here. We can see those here. So here's our credits and our assets. And if we go into this one, credits, we can see that there was a mint of 100. And it was from the 0x address. That means it was a mint these were new tokens that just came into existence, and we sent it to Bravo Inc. over here. Okay, so Bravo has some credits now in our ecosystem that they can do something with. That's great. What we're going to do is I'm going to open up Bravo's API, and I'm going to transfer some of those back. Actually, I can do this even quicker from Bravo's sandbox. I'm going to go to the tokens, and I'm going to go to transfer tokens. So I have some credits here. I'm going to send 10 because that was what we set the cost of the NFT to be. And I'm going to set the recipient to Alpha Corp. So basically we minted 100 to Bravo, and now we're going to send 10 back to buy this NFT. And let's just take a peek over here. So haven't logged anything in our app yet. Firefly WebSocket is connected, so our app is listening. And when we run this, we should see over here, we received 10 from, this is Bravo Inc.'s address, and minted an NFT to Bravo Inc. Okay, cool. So our app saw that, and it did the NFT mint there. Now we should be able to go back and look at our asset token pool. And now we can see that mint right there. So now we have one asset that we've created. It was just purchased by Bravo. And this was token index 1. And we can see that this was the signing key that created it. This was Alpha Corp, and sent it to Bravo Inc. right here. So that's pretty cool. And this is demonstrating 2 different Firefly nodes that are sort of working together. However, like one of the questions that was asked earlier, and one of the use cases that Shadman brought up was, integration, where like one of the really cool things about blockchain is interoperability and its decentralization. So to interact with these contracts doesn't require that every end user actually be using Firefly. So as a developer, I can build, I can write my smart contract, I can deploy it, and I can build an app that uses Firefly as my platform to build all my Web3 infrastructure. And then other people can interact with my smart contract on a public chain or in a private consortium chain if they need to. And my app can still see all those transactions because they're on the blockchain, and Firefly is listening to that chain. So what I'm going to do now is I have my MetaMask wallet over here as well. And before the demo started, I've gone ahead and I've connected my MetaMask wallet to the local chain that I'm using on my machine right now for this demo. You can connect MetaMask to a variety of chains. There is a tutorial in the docs on how to do that specifically. For the sake of time, don't have time to show you how to configure that, but there is a page in the docs that goes over that. So what I'm going to do now is I'm going to copy my MetaMask address, and I'm going to do the same thing that I did earlier. I'm going to go back to the Swagger UI here, and now I'm going to send, instead of sending it to the other Firefly node, I'm going to send 100 tokens to my MetaMask wallet. Now, MetaMask, when it's running against a local chain, doesn't have contract discovery enabled. That's one of the features that it relies on some other infrastructure for on public chains. So we have to tell MetaMask, hey, there's this contract address out here that I want you to pay attention to. We can find that by looking in our token pools page under the credits pool, and we can see our contract address is right here under the pool info. So I'm going to copy that. And then I'm going to go tell MetaMask to import a token. And I'm just going to paste the address in, and it automatically discovers on the chain, oh, this is the cred token, and it has 18 decimal places. So we'll import it here. Okay. Oh, and it sees already that I have 100 of them. That's cool. So now I should be able to, using MetaMask, right, I said that we were going to refer back to our picture. Let's go back and look at this picture. So up until now, we've just been working with sample app and Firefly nodes. Now we're going to introduce a completely third-party wallet. It's not running on a mobile phone right now, but for the sake of the argument, it could very well be. It's just another wallet app that's connected to the same chain. Now this wallet app has 100 credits, and it's going to transfer 100 of those credits to my FireFly address, and then the app will mint a NFT to that MetaMask wallet. I don't have a fancy picture set up to see it in MetaMask, but we'll be able to see that it shows up there still. Okay, so what I'm going to do now is I'm going to hit send, and I need the address of Alpha Inc. So I'm going to go back to my organizations tab here. Sorry, Alpha Corp, what I called it. Copy that. And I'm going to send 10 credits. The limit on the gas here, gas is free on this chain. So I'm going to set the price to 0 and just put in a big limit. It doesn't need to be that high, but just to get MetaMask to submit the transaction. So I have 100, I'm sending 10 because it's a private chain running on my machine. Gas is free. I'm going to hit next. There's no conversion rate. Yeah, that's fine. And I'm going to confirm the transaction, and it's currently pending. This one from yesterday was me testing this. So that don't worry about that. And let's go back here to our app, and hasn't seen it yet. This did work yesterday when I tested it. Let's come on, MetaMask. I don't think so. Speeding it up would add more gas, but I don't think that is the issue. We can try it. I don't think that's going to do anything though. I suspect me resetting the chain before the demo has confused MetaMask because it was previously connected to the chain and it doesn't realize that it's a brand new chain. So unfortunately, this last step of the demo doesn't quite transfer, but I can assure you that it does when MetaMask is working right. Our app sees the transaction here and will also mint an NFT back to MetaMask. And unfortunately, that it's not going to go through at this time, but it's just a cool visual example of like how you can work with both transactions within a FireFly network and transferring these things between different organizations that are using FireFly and third parties. And we were able to see that. We were able to see in our MetaMask wallet that we're able to mint tokens and send them to the MetaMask wallet. There's just currently an issue with this wallet submitting transfers itself, but we can see that interoperability working there. So that is what I wanted to demo today. Thank you very much for watching, and hopefully you're able to kind of follow along. I know I was moving through that really quickly. Again, this is being recorded, and the source code for this is available on GitHub. This is in the FireFly samples repo. It's at github.com/hyperledger/FireFly samples. And again, this is the fungible to non-fungible token sample here. And so you're welcome to run this on your own machine if you'd like, and go back and watch this video as a walkthrough on how to set everything up. And the docs should provide pages on how to set everything up on your machine if you're curious and want to try this yourself. But that's what I wanted to walk through as the demo today. So thank you very much. And we've got a few minutes left, and I'll save the rest of the time for a bit of Q&A here at the end. Well, I'm going to catch up.
You got some good questions around FireFly, if it's built on multiple blockchains or not.
Awesome. And apparently I named the pool name Assert. Yeah, that's maybe my love of unit tests is leaking through there a little bit. or maybe I'm just bad at typing in real time. Sorry about that. Is this Polygon Edge? No. So this specific, what I showed today was actually a local private chain running on my own machine. It was using a Go Ethereum node, which is the default when you run the FireFly CLI. Sorry, I skipped over that detail, but it certainly can work with Polygon Edge. It can work with any FireFly works today with any EVM compatible chain through the EVM Connect blockchain connector. It also works with Hyperledger Fabric. It works, and there's a brand new Tezos blockchain connector as well, which is Still, it's functional and it's deployed in some production use cases, but there are still some features that need to get implemented on that one. So does FireFly work with multiple blockchains? Absolutely. So the way FireFly works with multiple blockchains is in FireFly, we have this concept of a namespace, and there's a great page in the docs that talks about namespaces, how they work, how to configure them, that sort of thing. But each FireFly namespace can use a different blockchain plugin and connect to a different blockchain. And you could build apps that work across namespaces. So you might have one namespace set up to be your private multi-party consortium network, and you might have another namespace set up to be your a Web3 gateway to a public chain, and you might have an app that's performing transactions on both of those. Okay, let me just scan through the rest of the questions here. Will FireFly support EIP 433.7 account wallet services at some point versus wallets like MetaMask? Potentially, it's a great question. Let's take that one offline. That would be great to talk through. A non-creds framework. Fabric work with FireFly. I personally don't. I'm actually not familiar with the non-creds framework. So off the top of my head, I'm not sure how that would work. It may, but would love to chat about that one too. Thanks, Jim. Great questions. Sorry, I don't have an answer off the top of my head on those. Is there any drawback to just monitoring events on a token contract without creating a token pool? There are a couple of cool features that FireFly enables that you don't get. It's a great question. So there's two ways you can work with custom contracts in FireFly. One is there's sort of a more bare bones custom contract API, and it lets you invoke any function on your contract. It lets you listen and subscribe to any event from your contract, and you can work with a token contract that way. And if sometimes actually with a complex contract, these are really simple token contracts, but if I had custom functions that I had added on top of what's defined in like ERC20 or 721, I might actually do both. I might create an API for it and invoke my very custom functions in my contract. But the things that I'll just share my screen real quick one more time. The things that using the tokens APIs through FireFly gives you are automatic indexing of the token contract and tracking balances. So if we go in here to the credits, we can see the accounts in the pool and who has. FireFly actually tracks the balances. So as tokens are being transferred back and forth, we can see them updated in real time. This is one major feature that you get with using FireFly's token connectors and the tokens APIs above just subscribing directly to the transfer events from your application itself. So hopefully that answers that question there. All right, we are at the top of the hour. I've got maybe time for one more question though. And great questions, great engagement. Thank you, everybody. Okay, well, if that's it for questions, then I think we can wrap it up. Thank you, everyone, so much for coming. Shadman, thank you especially for just a really great presentation, and just super excited to see all the cool use cases that are being enabled by FireFly and accelerated by FireFly in your business. So thank you so much for coming and presenting today. It was great to have you.
Yeah, thank you for having me.
All right, well, thanks, everybody. We're going to go ahead and wrap it up here. If you weren't able to catch all of it, this is being live streamed on YouTube, and you can find that in the Hyperledger YouTube channel, and it will be preserved there as well. So if you want to go back and watch the recording later, and so thanks again for coming out, and we're going to wrap it up. Thank you so much. Have a great rest of your day. Bye, everybody.